Okay, I think we can get started. Good evening to everybody, and thank you for firstly registering in this course, showing for your interest in the course, and also thank you for showing up for the live session. Yeah, I think this is a open format session. I know that some of you have posted questions. So what I will perhaps do is walk over those questions. Maybe I can discuss them one by one. But I feel we should have sufficient time to also take questions from any of you live here also. Maybe if one of the TAs are here, if Rishabh, are you here?
Yes, I am there.
Okay. If it's okay for you to also look at if any questions come up on YouTube, if some of you can just post it here, that will greatly help. In
Sure,
case,
sir. I'll look into that.
I'm not to pull it up, you can just probably paste it on chat here so I can pull it up.
Sure, sir.
Thank you. Yeah, thank you for that. So maybe just as I think yeah, all of you have already gone through 2/3 of the course. I think we are now in the last third probably the last 1/3 segment of the course. I do hope it has been of some use to all of you. And just to probably quickly give an overview, so this course has changed from this year. So this is perhaps the fifth time that we are offering this course, and the last 4 times we offered, we had a broader set of topics. And based on the feedback that we received from students over the last 4 years, and also I think the nature of topics have also evolved over the last few years. So we decided to streamline the topics a bit more and focus on the important ones and remove a lot of unnecessary content. And that's something that we attempted from this offering, which all of you are a part of. So we'd be very happy to hear from you on things that anything can be improved to. Happy to take suggestions on that. We ideally want this course to be useful to as many of you going forward. Okay, with that brief intro, let me go through the questions that have been shared. But please do feel free to interject, ask questions. I'm happy to stay on for any questions that any of you have. Okay, I've pulled up I think many of you have filled up the Google form with your questions. So I'm just going to walk over one by one there and answer questions and discuss. But please feel free to interject, either unmute and ask questions. Only thing is, after asking a question, please mute back so that there are no audio issues. Otherwise, please feel free to type your question on chat. Okay, I'm looking at the questions. So the first one, okay, the first one is from Veeranagoda, but I think there's no question there. So I'm going to move on to the next one. The first question that's on the forms is from Sheetal Amit Karande. Sure if Sheetal is here. But let me read out the question and then I'll try to answer it. So the question is, I work in the domain of image processing and deep learning in my PhD research work of computer engineering. Can I choose only 10 to 11 disease classes of one plant and explore lightweight models? Is it required to work on more than one plant? Since, as per my knowledge, Agriculture Institute studies and explore one plant within depth. My other point is how to justify novelty in research since this domain is widely explored. Yeah, probably I should prefix by saying I'm not an agriculture expert, so bear with if my answer is not complete. I'm not sure if Sheetal is here. Okay, maybe they joined on YouTube. Let me go ahead and answer it. So I'm not an agriculture expert. So since the query is more about related to the study of computer vision from a PhD perspective, I assume publications are what matter here, which means I think the answer to Sheetal's question depends on what venue you're publishing in. If you're publishing in an agriculture journal or conference, you're absolutely right. Perhaps focusing on one plant and very comprehensively studying it may be more purposeful. But if you're planning to publish this in a computer vision conference or a journal, then you may want to look at multiple data sets because often the focus in computer vision is to study methods, improve methods, and show the generalizability of methods, right? So which means you want to show a method works on multiple data sets. So that would be my answer to Sheetal Amit. Not sure if they're there here or on YouTube. If they have a further question, please feel free to ask. I'll just pause for a moment to see if there are further questions. Okay. If not, let me move on to the next question. The next question is from Saurashish. And the question is, what is the difficulty level of the final offline exam? Some of the questions in the assignments were pretty tough. Will it be easier in the final exam or same? I'd like to say the difficulty level will be about the same. So at the end of the day, I mean, it's all of you have the same question paper, so it's between all of you. So the difficulty level of the final exam will be about the same as the assignment. So you could expect similar questions too. Again, for some of you who are asking this question, the final exam, offline exam, will not have programming components. It will be largely multiple choice questions, fill in the blanks, match the followings, things of those kinds. It will not have programming components for obvious reasons. But the difficulty level, probably the kind of questions you can expect will be about what you saw in the assignment. And otherwise, the exam follows the typical guidelines of an NPTEL course. About 1/4 of the questions from the exam will be from your assignment. So please do go through your assignments well. And the questions may be of similar kind as the assignments too. I hope that question is answered. Let me see if there is a follow-up question here. Okay, I think there are some questions on chat. I'll come to that later. Any follow-up questions on this answer that I gave about the exams? Let's first focus on that if you don't mind. Any follow-up questions on this answer? Okay. If not, let me probably move on to the next question on the Google form. The next question on the Google form is from Anjali Joshi. And the question is, due to my illness, I was not able to submit assignment 1 to 5. How can I submit them now? Anjali, if you're listening either on the Zoom link or on YouTube, I'll request you to please check with the NPTEL office on this. I think anything related to the administrative aspects of the course, if you missed a test or any of those aspects of this course, I'll request you to please write to the NPTEL office for their answer. I mean, you can also post on the portal if it's helpful, but the administrative aspects of the course will probably have to come from the NPTEL office. I hope that answers the question. Okay, any follow-up question on that? I'm not sure whether Anjali is listening or any follow-up question on this. Right. Okay. Let me move on to the next question. So just to let you all know, I just want to respect the fact that some of you submitted the questions on the forms. So we'll go through the questions on the forms first. Okay, then we can do other questions that are on chat and YouTube. Okay, so the next question that I see that was submitted through the forms is by Shivangi Agrawal. Shivangi asks, the programming questions seem to require search through PyTorch libraries. Will they be asked in the examination? I think I probably already answered that. No, programming. I mean, you could have very simple questions like if I gave you a particular operation, a multiple choice question on what is the right Python statement for that, those kind of things, maybe 1 or 2 questions, but otherwise there's no heavy programming question. I hope that answered that first part of the question. I think Shivangi has a second part of the question which asks, numericals are tricky, please guide how to prepare for them. As I said, I think the questions will be similar to what you saw on the assignments. I think a lot of these questions in terms of the numericals depend on your understanding. The reason why we have numericals is just so that some of you who have worked hard, you don't need to rely on luck to choose one of 4 options. Numericals give a better sense of whether you're able to understand and work through things, work through concepts. So if you generally understand the topics that you've studied in this course, you should be able to work through the numerals, right? So for the numerals, for example, could be about taking a kernel and convolving it on an image. And if you knew what the convolution, a particular convolution filter, how convolution operates, how a particular filter operates, that should be fairly straightforward. But or we could ask you like take a YOLO object detector and tell us how many parameters it could have, things of those kinds. So generally, when you understand the topic, you should be able to get the numericals. And there is also some tolerance level for the error. So let's say the exact answer is 8.20 and you say 8.201 or things like that. That's already pre-built. That kind of tolerance level is already built, right? So into the system. So those kind of things will still be awarded marks, right? If at all that's a concern for any of you. That seems to be Shivangi's question. I'm not sure if Shivangi is here, but any follow-up questions on that? Did that answer the question? Did any of you have a follow-up question on that? Yeah, I'll come to the questions that are coming from YouTube after we finish the Google Form questions. Okay, and let me go on to the next question from forms. The next question is from Monojit Sarkar. And Monojit's question is guidance on understanding mathematics to come up with new AI algorithms. Okay, this is, not a very straightforward answer. I think it's not a very linear answer for that matter. To understand mathematics, so it depends on what you want to come up with new algorithms for. Do you want to write a paper or do you want to come up with algorithms that work in the real world, right? So I think each of them probably have a different approach. If you want to write a publishable paper, then the way you have to think is slightly different. And if you really want to come up with an algorithm that works in practice in a particular setting, the way you work is different. Right. So I assume the question is more about, okay, I do see Monojit here. So please feel free, Monojit, please feel free to interject and ask a counter question. But in terms of understanding the math itself, this comes from experience. So it's not trivial to directly, even if you've done a math major or a math course, it's not that trivial to know how to translate that to an algorithm. So that requires practice and experience. So the only thing that I would say is stay at it and don't try too many things. It's nice to probably decide on a particular problem space where you want to contribute. Go deep into the algorithms that operate in that space. Understand the math behind the algorithms in that particular space. And now try to see if you had to change one mathematical equation in that, what would you change for that particular problem space? So that's generally the sequence in which you want to go and operate, where you first begin with sticking to a space, right? It's very hard to make a new contribution if you change problems too often, right? So then you would not know how to make a contribution. So I'd suggest sticking to a specific problem space, understanding the algorithms in that space first, understanding the math behind the algorithms in that space next. The understanding at a certain depth is key. Then you go to that depth and see now, let's say you understood the math behind the algorithms for a particular space. When I say the math, what I mean is, let's say there's a particular problem. Let's say you have object detection, for example, right? So I'm just going to take one example there. Let's say you studied the YOLO family of algorithms or the DETR family of algorithms. You've studied the faster RCNN family of algorithms. Understand them in their completeness, right? So understand every equation in all of these methods. Ensure that you've understood every step. I do want to qualify this by saying that it's very hard to cover every method to every detail in such lectures, right? So that we do on NPTEL. So you may have to do some reading beyond this if you want to go and innovate at your own level. But the hope is that these kind of courses give you the platform and the confidence to be able to study these methods, right? So that's what the hope is. So then once you've understood the math, now you ideate to see what can you change in the math that will probably go and change the algorithm itself. So some part of it also requires mentorship. Sometimes not very hard to completely do it on your own. So if you can find a mentor in your own organization, be it college, be it industry, or wherever you are, I think that could also help you make this process a little faster. Monojit, I hope I answered that question. Did you have any follow-up question on that?
Yes, sir. Can you hear me, sir?
Yes, yes, I can hear you. I can hear you.
Yeah, yeah. Thank you, sir. Actually, I think I you have answered it. Like I get it, but the thing is, sir. Actually, sometimes I find mathematics very abstract. Like I have studied several papers, implemented them. I understood the mathematics behind, but what I'm thinking is, if in future I want to create a new algorithm that will work in real world, I find that math is too much abstract and
Right.
like concept to bring those concepts and solve some kind of real world problem. I find that right now at this stage of my life a little bit challenging, right? But I do think that that you suggested finding a mentor, I think that should help me, I guess.
Yeah. So finding a mentor is one thing, and my suggestion to you is uh, don't start with an objective of saying I want to do something mathematical to come up with an algorithm, right? So that's an abstract objective itself. Forget the math being abstract. Even that objective is abstract. What I'm suggesting is first understand the space thoroughly, including its math. Just understand. Don't worry about contributing. Contributing comes after understanding, right? So first understand the space thoroughly, including all equations, the math, everything, right? Then you think in that space for that problem, for that equation, what can you change in the math? Don't try to come up with a completely different math from a different subject into this, right? So let's say you suddenly want to say, I want to bring, say, real analysis or differential geometry or functional analysis or Hilbert spaces into a particular algorithm. It's very difficult to do that, right? You just cannot marry two things like that. The the more appropriate way is perhaps once you've understood a particular family of methods, go deep into it. Right? So first is code. First is reading paper, then is writing code, then ensuring that a particular paper may be using math from a different paper. You may have to go to that paper to understand the math. That paper may be using some other paper to get it. So it requires not just reading of one paper, it requires reading of many papers to understand the math behind a particular field. Right. And only when you want, and it takes many months to get that expertise, right? This is not something that you can do in a week or two. Right? It takes many months to get that expertise in a particular sub area. I'm not saying an entire field, just a sub area. And then you try to think in, okay, then you'll get a more consolidated understanding of how the math operates in that space. Then you try to see now what can I contribute, right? So the contribution part comes after understanding. That's the part that I'm trying to convey. I hope mentorship obviously helps. Obviously helps. I hope I was
uh,
clear.
yes, sir, that was very helpful, sir. Can I ask one last question, sir?
Sure, yeah, very much. Yes.
Yeah, so is it like I'm thinking if I should take one dedicated math course on, like, say, let's say linear algebra, statistics, and probability, will that also help? If I understand them, but I don't have that deep understanding of them.
Absolutely, yes. Right. So you should do math subjects. You do need math basics if you want to contribute that level. But some suggestions that I would give you is uh, please understand that research, innovation, these things are a marathon race. They're not a sprint. It takes some time to start making contributions, right? So you have to stay at it. These kind of things, let's say you do a math course and the next 6 months you're not able to make a contribution. You cannot afford to give up. It doesn't work that simply, right? So you just cannot take a linear algebra course and then expect that in the next 6 months you'll make a contribution. It doesn't work like that, right? So it knowledge is a journey. You keep accumulating it, and only as you accumulate more, you find new connections, right? And that's what helps you go towards actually coming up with
Eh, Mariana, kudu.
uh,
Bada kudu aja lagi no.
request some of you who are not talking to please mute. Okay. Yeah. So yeah, coming back to this, so it does take time, right? So now doing math courses is good. Please do keep in mind that if you do just a pure math course, right? Even if you do a linear algebra pure math course, uh, it may not directly connect to what you do in machine learning, deep learning, computer vision, right? So that connections are not evident, right? So sometimes you have to just only when you spend time thinking through it, you understand the connections, right? So, but what doing such courses gives you is the ability to be confident to read such papers to understand the math. That's the reason why you need to do math courses. I hope I answered the question, Manojit.
Yes, sir. Absolutely, sir. Thank you, sir. Thank you for your guidance. I really appreciate it.
Sure, sure. Yeah, happy to do this. And I see that you have a second question is how do you translate research paper to code?
Uh, uh, yes, sir.
Yeah,
Actually, on every research paper, like there are so many technical small details. So like that is really
yeah, I
hard.
can answer that. Yeah. I mean, the hope these days is that you don't need to do it, right? So in fact, it's a mandate these days in a lot of conferences that any paper that's published must have associated code or must have all the hyperparameters specified for reproducibility. It's in fact expected that any paper published these days must have that, right? So, and a significant body of papers actually do have that, where they either they release the code on GitHub, or if they cannot release the code, they give you all the hyperparameters required to train the code, right? So that's the ideal scenario. If there are papers that don't provide these things, then yes, it does become hard. The only thing is for you to try. A couple of things I would suggest for you is sometimes it's worthwhile emailing the authors and checking whether they can share the code. Some of them may not be willing to share the code publicly, but may be willing to share with just one person on a private basis for whatever reason, right? So it may be even some people cannot share publicly because they're part of a company where the code should not be shared. It's not that they don't want to share. For legal reasons, they cannot share, right? So then you can't do much, right? So then you can probably email the authors and ask. That's one approach. A second approach is you code the paper. Now you run the model, you run your code, train your model, and see whether you're able to get the same results as the paper. If you're able to reproduce the results of the paper, you have achieved your job. That's your litmus test, right? Your litmus test is whether when you run your code, are you able to get the same results as what they had in the paper? Plus or minus a few small like 0.01, 0.02 difference between your code and them is completely fine, right? Those kind of things are okay. It can happen due to statistical or random fluctuations. But otherwise, you expect that your code should give you approximately the same results as in the paper. That would be your litmus test to say whether you have run the code well. Let's say you've run the code, it's giving results, and you've checked it, the code has no bugs, it seems okay, it works the same way. The author is not willing to share the code, the author has not uploaded the code. You can write to the authors to say, I wrote the code, this is your result, this is my result. Can you tell me what could be going wrong, right? So one of them could, if they cannot share the code, they may be able to get back and say that this is the choice that we made, maybe this is the reason why it's different, right? So please do try to reach out. Not all authors respond, but many authors do, right? So it's worthwhile exploring that option to do this. Otherwise, I agree with you. I mean, the hope is that you don't have to write it, that people already share the code. If you have to write it, these are some suggestions to make it a bit more effective. Did that answer your second question, Manoj?
Yes, sir. And I'm also thinking for me to be able to reproduce the results, I also need the same data set. And maybe I also, if the data set is complex enough, I also need a powerful GPU also for that. I guess so. Yes.
Fortunately or unfortunately, yes. Right. So, and generally, papers that are published generally do it on public data sets. Right. So, very, very rarely are private dataset results shared in papers. Generally, most papers do it on public datasets. So, accessing the dataset should not be a problem. But yeah, compute is an issue, right? So, I mean, in my suggestion to you there is, if you think compute is a problem, then and you still want to publish a paper, do something. Uh, Pick papers where you think you can replicate the results using the compute you have. Don't take up a problem for which you may not be able to have the compute. Right? So you should also strategize there. Right? So if you think there's a particular paper that runs it on, say, a billion image data set, and you don't have the compute for it, just don't go to that space unless you have that compute.
Okay.
Right?
Sure, sir. Thank you, sir. Thank you very much.
Okay. Let's move forward. The next question is from Nishan. Okay, this is an interesting question. The question is, would it be possible to create a video lecture that briefly discusses the applications of the concepts we learned? For example, demonstrating how different tools like engines, tires, and chips come together to make an automobile. I think that's a good suggestion. I think we'll do our best to do that. Right. So I know there are only 4 weeks left. We had a plan for the 4 weeks. but I think it's a very nice suggestion. Probably we didn't think of it this way. We'll do our best to see if we can include one lecture on that. Yeah, thank you for the suggestion, Ishan. Okay, let me move on. For those of you waiting for your questions on YouTube, there are 3 more questions on the form. So once that's done, I'll come to the questions on YouTube and other platforms. So next question on the form is from Supreet Sahu. Looks like it's a 3-part question. The first question is, which is more rewarding for someone who aspires for higher studies in vision in top grad schools like CMU and Berkeley? Is it theoretical works in vision, like math-based works, or application-oriented works? It's an interesting question. Which is more rewarding? I think it's a very personal question. So everybody has their own reward function, if I can say so. Right. So some people like the thrill of theory, like the pleasure they get out of doing theoretical work. Some people like the thrill out of seeing something work in practice. Right. So I don't think one is greater than the other. It depends on what you have a natural aptitude for and where you think you can best succeed. Right. I don't think one is greater than the other, in my personal opinion. Both theory and application are equally important for the world. Some has immediate ramifications. Some may have more long-term ramifications, right? So I think that changes in terms of the scale, but both are equally important. And it depends on what you want to do, where you see your strength, and where you think you can be successful, right? If you're a super good programmer, right, then perhaps being on the applied side is better for you. If you're really, really good at math, right? So being on the theory side is good for you, right? Choose what works for you. Right? So that's I think, in my opinion, important. I don't think there's a very generic formula here. That would be the first part of my answer. The second part of my answer would probably be that at the end of the day, whether you do theory or application, what yields success is the rigor of your work, right? It's not about theory or application. Now, what do I mean by that? Is if you do theory, remember to make a contribution in theory, it takes a long time because it takes a year or so to understand the theory. Once again, just a call. If some of you is not talking, can you please mute? It takes a long time to make contributions in theory. Right? So because it takes a long time to understand, to actually start making contributions. From an application perspective, sometimes that initial cycle is quite short. Right? But in theory, once you have spent time understanding the fundamentals, it's very easy to start coming up with new ideas, right? Let's say you've understood the math behind a particular area, the theoretical side, really, really well. You spent a year and a half understanding all of that. Then it's very easy to, like in almost every other month, you can come up with a new method, right? So it's very quick. You take a long time to lay a foundation, but then after that, you can start building on it very quickly. In application, whenever you have to make a new contribution, you have to come up with a new thread, right? You cannot build on top of a previous application and expect each of them to be, say, a paper or a product, right? So those are the pros and cons of theory versus application. But I think at the end of the day, as I said, it depends on where you think your strengths are, where you think you can succeed. And irrespective of theory or rigor, the theory or application, what really matters is rigor. Right? You cannot really make serious contributions unless you're rigorous either with theory or with application. Yeah, I hope the word and what rigor means can be subjective, but I hope the context of that makes sense. I'm not sure if Supreet is here, but I hope I answered the question. Let me see if he's... Yeah, I think Supreet is here, so please feel free to ask a counter question if that did not. Supreet, did that answer the first part of your question? Yeah, okay, great. All right, let me move on to the second part of Supreet's question, which is, what are the trending areas and problem statements currently in computer vision which one can work on? How do you see the future of self-supervised learning, both from theoretical and application perspective? Right, so some of this we will touch upon in the last week of this course, trending areas and problem statements. I think there are quite a few at this point in time. So if you ask me what are some trending areas, I'm not going to say that my list is exhaustive, but I'll just share a few topics that come to my mind at this point. I think efficient deep learning. That means like making these large scale models, foundation models, work on, say, a mobile device or an edge device or a sensor or Raspberry Pi, things like that are open problems at this point. We don't have solutions there. I think that's a very, very open problem at this point. The broader area of responsible AI that includes explainability, fairness, privacy preservation, robust AI, all of that continues to be an open direction at this point. So that still is an open direction. Multimodal aspect of computer vision, right? So which is how do you bring vision and text together is already an important direction. I think I'm quite sure all of you know that all the recent versions of LLMs like ChatGPT 4o, Gemini, Mistral, all of them do multimodal inputs at this point. So that direction is also pretty important in computer vision. So what is important there? Obviously, the bigger problems there are taken up by companies like OpenAI, Google, and Mistral, and all of them. But there are problems there around how do you fine tune them, how do you adapt them to different domains, how do you do LoRa on them, things like that are still open problems at this point, right? So that's a third direction that I can think of. A fourth direction that I can also think of, obviously, is diffusion models, right? So most the Gen AI aspect of computer vision is diffusion models, right? So if you take DALL-E 2, Mid-Journey, all of those are all diffusion models working. So there is a lot of work today on studying the bias of diffusion models. I'm quite sure you may be aware that if you give a certain prompt, then many of these diffusion models have some inherent biases. Could be a race bias, could be a gender bias. If you say, draw me a president of the United States, right? So it may draw a male person. Is that correct? Could be a question, right? So should it be more generic than that? Is a question to have. So lots of issues around what could be the right way to generate these kinds of data. Lightweight diffusion models, unbiased diffusion models are also open problems. Those are some general things that I can think of at this point, right? So it's not an exhaustive list, but these are some problems at this point that you could take up. And once again, Supreet, if you have a further question on that, please feel free to ask. Right. So, but it's hard to speak more about this because I think we are also living in a world where things are changing rapidly. In my personal opinion, I actually think we are actually stabilizing now. Things were changing rapidly last year. I think we are going through a stabilization phase at this point that may continue for the next few months, where we may know more clearly what works for sure and what doesn't work for sure. But these are some threads that are open at this point. And each of these threads that I spoke about have multiple subproblems too, right? It's not like you cannot take them up. There are lots of subproblems in each of them that you can take up. I hope that answered your second question, Supreet. Again, if you have a further question, please feel free to respond. Let me go on to your third question, which is, can you give us an opportunity to work with you in vision projects and publication and top conferences if you succeed in this NPTEL course? I mean, yes. So in fact, some of the TAs for this course, I think both of them are here, Rishabh and Swarnim. They were both among the high performers of earlier offerings of this NPTEL course. In fact, it's probably interesting that they are now TAs of the same NPTEL course. So absolutely, yes, that's something that I personally try to do too. I mean, obviously, any one person cannot like mentor too many students in the country, but I'll be happy to do work with some of you at least that come through this course. Supreet, I hope that answered these questions. Did you have any follow-up questions on these, or did anyone else had follow-up questions on Supreet's questions? Okay. Okay. If not, let me move on to the next question, which is from Swarnim. Swarnim's question is, why is there a need for value in transformer? If we want to capture the bidirectional relationship between every tokens, you can just do it using Q and K, where K equals V. Why do you need a value to be different from key? Should not the value that is passed at the end be the same as the amount of relation between the two tokens? Can you give an illustrative example for what key, query, and value actually might hope to represent in a sentence? What was the intuition for creation of this structure? Okay, that's a mean, that's an interesting question. I'm not exactly sure. I'll give my answer to it. I'm not very sure whether my answer will be the only answer here. So I'm very sure that the people who tried Transformer, which is the original paper, would have tried this too, right? So I'm not very sure whether the paper has an ablation study on this. I'm not able to recall that, and I don't have a clear memory of whether there are other papers that study this. I'm very sure this would have been studied, and empirically it was found that this was the best option, right? So that part I'm quite sure. I can probably try to dig a paper and share it offline, but I don't have a reference right away. But I'm quite sure empirically this would have been tried. But having said that, why does this make sense? I think it makes sense because you are dissociating the similarity and what should pass through, which is actually powerful, right? Let me explain this in a different way, right? Hope you, maybe there's a response to Swarnim, and hope you see that keeping key and value separate is the more general approach. When key and value become the same, it's a specific instance of the general approach. A key and value can always be the same in a particular setting. If two weight matrices end up being the same, so be it. If value is different, that's the more general approach, right? So I think it's always good to favor a more general approach. Why does it matter? You're trying to say, let me explain this, right? So, let me explain this using a simple example, right? So maybe a little intuitive response to you, Swarnim, is, let's say you are all writing exams, right? Query is like a question in the exam. Your response is the value, okay, that you actually write as the response. Key is the code that you learned while memorizing or studying your questions in your offline step, right? You would have, whenever you studied a subject, right, you would have had a certain way of coding the information in your head. That's the key, right? What I mean by that is when you see a question, for example, you may have thought that when you studied, let me think, right? Okay, let me give you an example, right? So let me say that you were studying YOLO in computer vision, right? You may have in your head kept a keyword called grid. And you would have said that, okay, if they ask me a question related to YOLO, this keyword called grid is what I'll use to connect to that question. And based on that, I'll pull up the answer that I remember and I'll then write the answer. I hope you realize that there are three entities here: query, key, which is the encoded form of your knowledge which you want to use for indexing, and the final answer. Trying to use the answer itself for indexing is actually a waste of space, right? You don't want to use your entire answer to index, right? You want to use the key to quickly recall what is it that you wanted to come out with. And then the value is what you actually answer with, right? So that would be my intuitive explanation as to why you need query, key, value, right? So in fact, I've seen some interesting discussion on a software view to attention, right? So to this particular question, I once again don't have a reference to straight away do, but if I can, I'll share it with some of you offline. Where to say that a query key value is perhaps the ideal setup to do this operation of match, retrieve, and write, right? So I hope you see this query key value is like a memory operation. Value is like what you retrieve from memory, and of course, in transformers, all of these are implemented in a learnable way. Key is what you use for matching the index. Query is what is given to you as input, right? So these are the three different things. I've also seen some interesting software analogies as to why you need these three things, and that's the most optimal way to do it. I can share that reference with you offline, but hope this intuitive explanation helped, Swarnim. Maybe if you have a follow-up question, you can ask Swarnim, or if any of you had follow-up questions on that.
Sir, can you give an example of a sentence with, like, not saying that this is how model works, like, but how could a model work when a given a sentence?
It's not possible to give that, right? Because query key value are all just tensors. They're all just numbers. You don't have any semantics for them, right? I cannot tell you that here is the query, here is the key, and here's the value. It wouldn't make sense. They are all just codes.
So there has not been any attempt to, like, understand what they represent, what each of
No,
these.
not really, right? I mean, because if you could do that, then at the end of every attention head, you can write out a sentence. There is nothing like that. I mean, there are visualizations of attention, of the attention heads, but there is nothing to the point of saying that this attention head means this query vector means this key head means this. That level of semantics we don't have at this point. Right? At the end of the day, these are just codes. Right? Even query is a code, key is a code, value is a code, internally speaking. So there is no semantics at that level, at the every attention head level. So it's very hard to give an illustrative example at that level. But as I said, the intuitive thing is, I mean, for example, if I asked you, right? So if one of you wrote an exam, and you wrote an answer. If you told me, how did you remember that answer, right? For some of them, you'll be able to give an answer. For some of them, even you may not be able to remember how you memorized it. Some of them you may have had a code, but for some of them, it's just your internal memory process as to how you remember things. You cannot verbalize it. You cannot verbalize all of it, let me put it that way. It's the same thing in a transformer, right? So, for example, you're speaking now from some memory. Can you tell me how you retrieved it? Can you give me that exact word and sentence as to what you accessed and how you retrieved it? You cannot, right? It's all encoded in some encoded form in our brain. You are speaking out something which is the final output. You don't have the semantics for how it is stored in your brain. That would be the equivalent, right? So did I answer that question?
Yes, sir.
Okay. Any other follow-up questions on that from anybody else?
Hi, Akash this side.
Yes, Akash.
Just one follow-up question on this. Like, currently, I've been working on two LLM, and my current project that I've been working on is also based on LLM. So I wanted to pull the vision information as well here, but the compute was pretty high, so I didn't opt for that. But right now, what I've like on the research and reviews that I've done, I've seen that this year and specifically last half year was mostly towards the evaluation processes of the LLMs. And when I was trying to, approach or you can say implement these evaluation techniques, like I tried Guesscard, I tried with Ragas as well, but I found like some of the evaluation techniques were not that clear. I was thinking in a way that maybe if I introduce a vision, a technique there using maybe any diffusion model here in this case, so that I can visualize some part of it where an evaluation can be fit in to see whether, because right now I'm really unsure what's happening in the background. So just to have a visualization on the evaluation, like is that possible with the vision models that we have to understand what's going in the background side?
Okay. Yeah, I think your question has many layers, right? So many layers, right? So it's very hard to, I think there are many things that are probably conflated in your question. You're absolutely right that the last few months there has been significant efforts around the world on evaluating LLMs in a common way, right? So in a common way, understanding what they're capable of, where they fail, where they do well, all of those things. It's absolutely yes. I also think there's another parallel effort which is on miniaturizing them, small SLMs for that matter. That's also another effort, right? So that's also going on. These are probably the most popular efforts that are going on at the LM scale. Now, in terms of what you can do from a vision perspective, completely depends on what you want to evaluate, right? I don't know, when you say LLMs, do you want to evaluate uh, the ChatGPT 4o kind of models? Do you want to evaluate the DALI 2 Midjourney kind of models? It depends on what is it that you're evaluating. For each of them, you'll need a different tool, right? And visualization, if you see, visualization is a slightly overloaded word. For example, I could take a ChatGPT or any GPT version for that matter. I could simply visualize the attention heads in every transformer block of GPT. This is also visualization. Right? This is also visualization. To what end is not known. Right? So can you probably qualify by saying what did you mean by visualization? Right? So it depends on what you want to achieve. I think visualization has to be a tool towards an end. So what end do you want to achieve by visualization?
Okay, well, actually, like I was thinking on this side, as in like how it came to that result or the response after all of that information was fed through it.
Sure.
Like, is there a possible model which works in parallel to it which loads up all the features which was passed through that model and try to put that into vision to create a,
Understood. Got it. Okay, I
generate
got
an
your question.
image kind of.
I got your question.
Mhm.
So this entire space is generally called mechanistic interpretability. So there's an entire community that works on mechanistic interpretability that tries to understand how these things work. Right. So there is a lot of work in that space. I mean, they have something called sparse autoencoders, where they take the output of every transformer block, send it through a sparse autoencoder, find out what it actually is providing at that stage. So, have there been any groundbreaking understanding through that? Not yet, right? But there are efforts, right? So, I would suggest you to probably look at diffusion. Won't make sense there because diffusion is a generative model. It's a stochastic generative model, right? So you sample and generate, right? But if you want to understand what is already going on in a trained model, you shouldn't stochastically generate. You should see what works in that setting, right? It's more visualization than generation. So I'm not sure whether diffusion is the right tool there. It could be, but not as diffusion models are used today, not in that sense, right? But I would highly recommend you to look at the literature in mechanistic interpretability. I think there are works in that space that try to study this to understand the internals of these systems.
Great. We'll do that. Thanks so much.
Sure. Very much. Okay. There's one other question that's on forms, and then I'll come to the YouTube and the chat questions. The question is from Shubham Kumar. This is the last question on the form, which is, how do I find which area of research to work and get papers? Means finding the gap in someone else's research and completing it. Okay, that's an extremely open-ended question and a difficult question. If it was a simple answer, many people would have done it, right? So, Shubham is here, but yeah, I think for anybody who's doing research, I think it's a very important question, but it's not that simple a question. So at a broad level, I would say seek mentorship. Right? So mentorship is important to, I think that's where the role of a supervisor is, to probably guide you in that direction to know where something could give you results and where something may not give you results, right? So that's the role of a supervisor there. But that's one thing. But otherwise, it's not that trivial. I mean, my suggestion to you is be willing to spend time on it for some time. Pick a problem space. In fact, my general point is pick a contemporary space. Don't pick something that's very old. Pick a contemporary space. We just discussed a few topics in the last few minutes. Pick a contemporary space. Aim to get a solid understanding. I think my answer to you, Shubham, will be very similar to the answer that I gave Supreet some time back, which is understand that space properly first. Understand all the algorithms properly first. If you get superficial understanding, you will only be able to fill superficial gaps. If you get depth of understanding, you'll be able to fill gaps at a deep level, right? So it's as straightforward as that, right? So it's important to get depth of understanding on any topic that you do, not just superficial understanding. By superficial understanding, I mean, if you simply read a paper in one day, you get a certain understanding, right? If you read a paper and mull over it, think over every step of it, see whether you've understood every part of it. If you can help somebody else understand that paper, right? That's when you have understood the method, right? And if at that stage you feel you've understood the method well, then you understand areas, other papers in the area, understand the method well, get good depth of understanding. Then you try to think, where can you improve, right? At that stage, when you want to ideate to know how you can change things, it's very useful to have a mentor. Even if you don't have a mentor, it's very useful to have a discussion partner, right? So I would recommend, I mean, I do understand that not all of you may have access to good mentors, right? So it's hard, it's not, and probably, even I would have gone through that stage at some point in my life, right? So everybody goes through that. If you don't have a mentor, at least have a discussion buddy group, right? Form reading groups in your own institution, like form like-minded people, talk to like-minded people. I mean, there are also online places like ML Collective and so on. So where you can probably sync with like-minded people, discuss ideas with them, right? So a lot of ideas come when you discuss, right? It not just comes from uh, because somebody has more knowledge than you. It just comes from pure discussion. That's all, right? When you discuss, you understand some things that could be improved. It's the same thing. So that's generally the way that you ideate and come up by fixing a gap in a particular area. That would be my high-level response to you, Shubham, but any further questions on that?
Thank you, sir, for answering my question. Sir, luckily I have, sir, I am working at Dr. Chalawada Vishnu, sir, and he's one of your student only.
Sure, sure.
Uh,
Yes, yeah.
uh,
Yeah.
so, and yes, sir, I liked your suggestion, sir. I will now dig deep into any paper, sir. I will read that.
Yeah, and you will finally make contributions at the level of what you read. If you understand a paper superficially, then that's the level at which you'll contribute, right? So it's as straightforward as that, right? So if you understand something in depth, then you'll also contribute at the depth level. Okay. Hope that gives some pointers to you, Shubham. Okay, that's the number of questions in the form. Let me move on to this chat here. I'll request Rishabh and Swarnim probably to please post any questions from YouTube on this chat. I'm just going to pick up from here. Shubham, looks like you have one other question, which is I want to learn 3D reconstruction. Can you suggest some resources? I think if in the first lecture of this course, in the very first lecture in the first week of this course, I've suggested a book for anybody who wants to do a geometric approach to computer vision, including, if I'm correct, I think I also have a reference to video lectures there, right? A book and video lectures. Please do look at that. That would be one of the best references that comes from the VGG group in Oxford. That's one of the best references I would give you to study any aspect of 3D reconstruction or geometric computer vision. Please go back and see the first lecture in the first week of this course, right? The last few slides give references for such topics. Please do look at it. Hope that answers that question, Shubham. Okay, let me move forward in the interest of time to the next question. The next question on chat is Shubhangi. The question is, I'm trying to work on vision transformers for breast histopathology images. How to fine-tune VITs for better accuracy? Okay, we are yet to do VITs in this course. It's probably coming in the next week for all of you. How do you fine-tune VITs? I mean, I'm not sure what to say, but you have to fine-tune them. I don't know what else you can do. You can, of course, use methods like, if any of you have heard about LoRa, Dora, Mora, they're all low rank adaptation methods. They help in fine-tuning transformers quickly. So I would recommend those kind of methods to fine-tune. But the only way you fine-tune is by having a set and by trying it empirically and seeing what works. Right? It is an empirical process to fine-tune. You may have to try it and see what works. But I would highly recommend methods like in the, again, Shubhangi, if you have not heard about LoRa, Dora, Mora, those family of methods, please read them up. LoRa stands for low rank adaptation. And then there is a family of methods based on LoRa. So that's some, LoRa is of course more for, was originally for NLP, but then there are variants of that for VITs. So that's what I would recommend for you to probably fine tune VITs for better accuracy. That would be my first answer at least, but I hope that answered the question. Shubhangi, any counter questions on that?
No, sir, I'll go through that first.
Yes, that's where I would suggest you to start at least. Please do read that literature. Okay. Let me move on to the next question. I think the next question is from YouTube, which says, I'm not sure who this is, but I'm working on medical image segmentation on medical images. What considerations should I have for creating and training the model? It depends on your objective, right? It depends on whether your goal is to make it work on some hospital data or you want to publish a paper, right? So the considerations would be completely different in each of these cases. If you want to publish a paper, your consideration would be on where can you add novelty? Can you reproduce the results from an earlier work and where can you add something on your own? If you want to actually make something work in practice, then your issue is, can you take an existing medical image segmentation paper, which has code, run it on the dataset where you want it to work and see what the accuracy is. And if the accuracy is not good, if the performance is not good, can you understand the failure cases and what are unique in the failure cases, right? So for example, what are unique in the sense, what I mean is look at the failure cases to see, do you see some commonalities? For example, if let's say a particular medical image segmentation model fails, whenever you apply it on a particular image which has a particular background, for instance, right? So particular text is written on that chest X-ray or CT image or things like that. Then you identify that particular failure case as a common failure case across images, and now you try to see how can you improve your model to address that failure case, right? And then you improve the model, right? So it's an iterative process to slowly improve it, right? But as I said, I think it depends on what you want to achieve. If you say, no, I'm not interested in a product, I'm not interested in a paper, I just want to learn, right? So then the approach is to probably ensure that you understand every line of your code, understand every line of the method and the paper, right? So each of these cases is perhaps different. So I would suggest, depending on what you want to achieve, you should probably focus on different things for this particular problem. I'm not sure who asked that question on YouTube, but hope that question is answered. Okay, I see another question on YouTube, which is, I'm from biomedical engineering background. My interest is healthcare, deep learning, and computer vision. Share about recent works that have gone in the field. Unfortunately, I don't work in that space, so I may not be the appropriate person to answer that question. But I'll highly recommend you to go through the conference called MICCAI, MICCAI, MICCAI. That is one of the best conferences in the field. I would recommend you to follow the latest MICCAI and see what are the hot topics there, and that's what you want to build on top of, right? So that's what I would suggest. I mean, I have some ideas, but I don't work in the space, so I may not be the right person to tell you what is most recent. But it's a very simple answer to say, go to MICCAI, just look at what are the latest papers in that space, look at the trends, and that should give you answers as to what areas you should focus on. I hope that answers this particular query from YouTube. Okay. Okay, I hope I answered Mojit's question already. Let me go on to the next question. The next question that I see on chat is from Pavani. Pavani's question is, in exam, do we get the same questions from assignments? This is my third time to give the exam. Kindly provide us assignment solution explanations. Okay, I mean, I would recommend if you want an explanation for a particular assignment, I'll highly recommend you to please post on the portal. The TAs do monitor the portal. We'll be happy to help you explain any answer there. Please do use the portal to ask targeted questions. For example, let's say you're not able to understand how a particular assignment question's answer came. Please do post your question on the portal, right? So that helps us understand your problem and answer. The TAs do keep monitoring the portal. We'll be happy to answer it. Please do also feel free to come up in the live sessions that are conducted by a few TAs every week. There are 3 TAs who are conducting live sessions every week. They will also be happy to answer if you have any questions on specific assignments. Please do use these sessions if you're not able to follow any assignment solution, right? So there are multiple sessions
Yes,
going every week, right? So please do.
sir, I attended all the assignment, problem solving sessions, sir. But the
Sure.
thing is, after solving the assignment solution, after the due date, they are evaluating our assignment. At
Right.
that time, the assignment, the question and answers are not stable, sir. Till the
Absolutely.
finalization of.
No, I understand. You can ask the question even then, right? So please ask this question in one of the NPTEL. I mean, it's very hard for me to give a generic answer at this point. Please ask the question. Come back to one of the live sessions and say, I have this question with this assignment, right? So, or please post on the portal. Say that I have this question with this assignment. So we'll be happy to answer it. So please do. I mean, the more targeted you keep your question, right? So please ask. The more specific you are about your question, it helps you answer. Right? So if you say, for this particular assignment, I see that this answer and this question don't match, right? So can you help explain? We'll be happy to answer that. So please do ask, right? So, but the more specific you are, it helps us give you an answer.
Okay.
Right? So there are multiple platforms. Be the portal or the live session, please do ask. So that's the way we could help you answer, right? So I'm not denying the fact that we may have made errors. Many times when we have made errors, we tell the NPTEL office not to consider a particular question in an assignment. This happens too. We do our best to avoid errors, We review it at multiple levels between us, between the TAs at myself, at my level too. So, but then if there are errors, we do have nullified questions in the past, right? So, but unless you point out, we won't know what to do. So, feel free to ask these questions on the portal.
Thank you, sir.
Sure. But to the first part of your question, do you get similar questions in the exam? Yes, right? So it'll be similar questions in the exam. In fact, at least a quarter of the exam will be almost the same questions from the assignments, right? Almost, with minor changes. So please do ensure that you prepare your assignments well for the final exam.
Thank you, sir. Thank you.
Sure. Let me move on to the next question. The next question is from Ravi Kumar. The question is, I'm an entrepreneur and would like to understand how can we assess the practicality of a model? Right? Okay, that's a very, very interesting question. I'm not sure if there is anything well studied for that. How can you assess the practicality of a model? For example, how do you map a problem statement to the right model? Probably a future generation of ChatGPT would do that. I think it's a very interesting question. I think to some extent that's the job of AutoML. I mean, I think the entire space of AutoML, if you've heard about, is essentially that, right? So it's given a problem or a data set. AutoML, there are multiple solutions for AutoML online. The idea is to probably try to see which model works on that data set and give you that, right? So I think you do already have that level of engagement at this point. But otherwise, if you want to directly talk about practicality of a model, I'm not sure whether that formula is straightforward. It depends. And for example, I can even give you like more specific things, right? So let's say somebody has developed a solution, right? Since there have been a lot of questions on medical imaging. Let's say somebody has come up with a solution for detecting a particular disease in a CT scan in Western countries. And you have a particular model there. Now, will that work for Indian patients? There's actually no answer for it unless you develop a data set and try it. It's very hard to come up with a formula for that, right? So the only way is to try it. So the only thing that I can suggest is definitely explore AutoML. That's one suggestion for you. That's a good place to start. Before you try too many models, try AutoML for sure. But otherwise, please, one of the things that's often understated, right? Probably, I mean, this is something that should probably be offered as a course by itself, perhaps, is how do you develop a data set? It is actually not a trivial thing, right? It's non-trivial to develop a data set which captures the way you want to study the real world, right? So, but to see the practicality of a model, ideally you should have a data set that captures the real world as closely as possible. If you can put in that effort of collecting a data set as closely to the real world as possible, the rest of it becomes simple because you can evaluate models on it and check how good they are. Your question, Ravi Kumar, boils down to how well then can you create a data set that's close to the real world. So, which is non-trivial, but if you can do that, the rest of it is actually a little bit more easier to do. But obviously that's easier said than done, but that's a skill by itself. And if you can do that, you can probably assess the practicality of a model far more effectively. Did I answer your question? Did you have a follow-up question on that?
Thank you, sir. Actually, I have two data sets. Both are related to extracting particular text from the image. Okay. One is related to metering data set. Suppose we have photos of meters, electricity meters, and we have to extract the particular meter serial number from the image. But the position of meter serial number is not fixed on the image.
Sure, yeah.
Okay, so I am not understand that which model is applied on these images to extract the particular meter serial number.
Sure. So there are already methods for this, right? So you should go look at this conference called ICDAR, ICDAR. Right. So this is a conference which works on. It was the conference where originally people used to publish OCR papers, but today people publish papers on how can you get text from images. There are already papers in this space. There are already papers with code in this space. I would recommend you to explore the latest IGDAR conference or the last couple of years of conferences. In fact, there's also an equivalent journal for it. I think it's called some International Journal on Document Analysis or some each. I think if you see IGDAR, you will get the idea of what the kind of papers are. So you then try to, once again, the key thing is having a data set which for you captures your real world application. And data set should not be one image, right? It should be at least 1,000, 2,000 images where you
Yeah,
want
I
to.
have 25,000 images.
Oh, sure, yeah, I get that, right? So now you go to the IGDAR conference, try to see which of those papers there have code and try to get text from images. Take their code, take multiple models, and now apply them on your 35,000 images and see which of them gives the best performance. Now you try to take that particular code that gives the best performance. It may not even be enough. Now you try to take that method and tweak its code to further improve its performance on your dataset. That's the way you have to do it, right? So there's an entire community that's been looking in this space for the last 25 to 30 years. It's the document analysis and retrieval community. It was the community that gave OCR solutions years ago. And that's the community that's currently working on how do you analyze text in images. For example, it may not be just numbers in electricity meters. It could be about in autonomous navigation. Somebody may want to find out what is the road name on a particular exit on a highway. That's also text reading from an image. All of these is addressed in this community's work, right? So that's the community's work I'll recommend you to go to.
Okay, thank you. And the second problem is also related to this. I am preparing a solution for small shopkeepers, a mobile-based solution which can get the item name and item type. It's a classification as well as test detection based model. I am searching for, but still I am not able to find the accurate model for this.
So what is the kind of images you get?
It's generic JPG images, simple.
No.
The material
What I mean
images.
is, no. In your real application system, will a shopkeeper take these pictures on a mobile randomly? Will somebody put each object on a stand, put lighting, and then capture it separately? How will the images look?
Shopkeeper got these images from his or her mobile.
Okay, so then you have to collect a data set of that kind first.
Okay.
Right. So without that, you cannot do anything. Right. So you first have to collect a data set of that type. And once again, it should be thousands of images. Right. So otherwise, you will not get a good sense.
Okay. Okay. Sure.
Once you have that, I would suggest then try some standard models. I would suggest you to try VIT based model for classification. I would also suggest you to try clip kind of models for trying to get the association between text output and images. Right. Or you can also do SAM models. I don't know if you've heard of SAM. SAM is something that we'll talk about as we go in the course. It's called segment anything. You can try all these models to first see how they work on your setting. Once you benchmark them, then you see whether you need a new solution or an existing solution already works.
Okay. Okay. Thank you. Thanks for suggestions.
Sure. Very much. Okay. Okay, let me move on. The next question is from YouTube, which is, how much is DSA important to succeed in the deep learning space? By DSA, I assume the question is data structures and algorithms. I'm not sure whether that's the expansion of DSA. Please correct me if that's not the case. I mean, it is important. I would not. These days, programming is becoming more and more abstracted. Python already has made a lot of abstractions on coding. With now Copilot and ChatGPT, programming is becoming even more and more abstract. By abstract, what I mean is a lot of things can already be filled in by somebody else for you. So, which means it is important, but then some of them can be automated too these days. But where does it become important is when you want to make things efficient. Right. So when DSA becomes important when you want to make things efficient, right? So you can make anything work, but when you want to make it efficient, then how quickly can you access memory? What is the right structure in which you want to store a set of vectors or tensors? All that become very important, and then DSA becomes important. right? So that would be my simple answer to this question, at least. I don't know who asked this question, but I hope that question is answered. Right? I again hope that I understood DSA correctly. Okay.
Sir,
Yes.
I think a possible question was about interview kind of thing. Maybe.
Oh, okay. I see. Okay. Okay. I see. I didn't get that perspective. Okay. Uh, yes and no again. I think it depends. Yeah, obviously, I think if you're looking from interviews perspective, yes, I think to this day, lead code and DSA matter a lot for questions. Yes. I think a lot of companies that recruit in this space will ask you questions both on the programming DSA front as well as on the deep learning understanding front. It's always good to be more well-rounded on both of these fronts. But I think these days there are also companies that are looking more just for understanding from a domain, from a deep learning space. So I think it depends. But yeah, if you want to succeed at the highest level, if you want to get to one of the Mang companies and so on, yeah, DSA matters as much as machine learning. That would be the simple answer. You do need to do lead code and other things also, along with learning your domain. I hope that answered the question. Okay, the next question that I see is, please give some suggestion on privacy preserving AI hardware accelerator using deep learning mode with Intel SGX Enclave and Homo. Oh my, okay, I absolutely have no knowledge about this. I'm not an expert in hardware. I think the question is too specific. I think the question is on, give me some suggestion on privacy preserving AI hardware accelerator using deep learning mode with Intel SGX Enclave and homomorphic encryption. Unfortunately, I'm not an expert on this. I'm not an expert on hardware security. So I would request you to please excuse me from this question. I just don't have the knowledge to answer this question. Okay. The next question is from Shubhangi on chat, which is, can we completely rely on GenAI code prompted by Google Colab for CNNs? No, right? So, I mean, Copilot or any version of Copilot is exactly what it states. It's a Copilot. It is not a pilot. So you are the pilot. So anything that it provides you, you should check the veracity of it. You should check the goodness of it and then use it, right? So you can obviously use it for help. So obviously, yes, but then you should definitely check the veracity of it and then use it. You cannot completely rely on it for implementation, especially in situations which have an implication, real world implication. I hope that answered the question, Shubhangi. Okay, the next question that I see on chat, which is again seems to be from someone on YouTube, which is, what are possible future directions on geometric computer vision for perception task? I'm once again not an expert in geometry computer vision. Maybe that is something that we didn't get a chance to cover in this course. But this entire direction of NERF is very, very hot in geometry computer vision. So I'll highly recommend you to look at NERF. In fact, the intersection of NERF diffusion is also very popular these days. So that entire space of intersection of neural networks and geometry computer vision, NERF is one example of that. I think is a very, very hot space. I think that's one very important direction. I think another direction that's also becoming very interesting there is the confluence of synthetic data and real world. How much can you develop a model on synthetic data and make the model applicable in a real world, right? So for example, let's say I take synthetic generations of 3D simulations of a city. Now I train my model for autonomous navigation on that synthetic data. Now, can I run a car in the real world? Will that really work? I think this entire confluence of how much is synthetic data useful for the real world, I think is becoming is a very hot topic these days. So that's also, I think, a very important thing to consider. I think multi-sensor fusion, right? Trying to bring LiDAR, depth sensors, all of that is also an important direction for this space, geometric vision itself. Yeah, those are some things that I can think of the fly from my hand. I think also bringing robotics into geometric vision, right, is a pretty futuristic direction. For example, that if you have a geometric vision, can you bring a robotic arm and use it to manipulate that space, right? What I mean by that is, suppose I use geometric vision to construct a simulation of or the environment of the room that I'm sitting in. Now, if I ask a question, right? For example, let's say I ask a question as to if I have a cup, where should I place this in this room? It requires a lot of deep understanding, right? It requires understanding of the affordances of different objects in the space. It requires of an understanding of what is the material that I want to place on that space. What is the material of that object there, right? Is it wood? Is it foam? Is it sponge? You probably cannot place a glass cup on sponge. It will with water on sponge. It may not have stability and spill. So all these also become important, right? So these also are very important directions as we go forward. As I said, I'll again say that I'm not an expert in geometry computer vision. I don't work in that space, and this course was also not in that direction. I hope, I mean, this was one thing that was stated the very first lecture too. But I hope they gave a few directions to who were asked this question. I hope that gave some sense. And as I said, this may not be an exhaustive answer because I'm not particularly an expert there. Okay. The next question is from IIITM, which is passing 10 to 11 papers in a year of NPTEL may be used to work on meaty projects like GATE or NET. Why not? I don't understand this question. If the question is more about how answering, like finishing about a few NPTEL courses can give you GATE, probably can give you the expertise to qualify GATE or NET exams, I would suggest to direct this question at the NPTEL office. I think they may be more the right people to answer this. I know that the NPTEL office also always keeps thinking of newer things. I know that they've signed a lot of MOUs with different IITs for people who to explore the use of NPTEL courses in different ways. So I would highly recommend the person who asked the question to talk to the NPTEL office on this. I think they may give you more visibility on. I think it's an interesting thought, but I may not be the right person to answer. I'll highly recommend you to talk to
Just to add to that, sir, there is a GATE portal of NPTEL which you can explore. So they have some mock tests going on.
Wonderful. Okay, great. Okay, I wasn't aware. Maybe you can share the link on the chat, Rishabh. That could help.
Sure, I'll do that.
Person who asked the question. Okay. The next question that I see is from Monojit. My question is a bit out of context with regards to the course, self-supervised learning and RL, reinforcement learning. Where do you think reinforcement learning stands according to Yanle Kun? Self-supervised learning is a dark matter. Can RL be used to solve real-world problems? Okay, I think some of these questions are very deep and very layered, I think. I mean, obviously, self-supervised learning and RL are very important. Just to let you know, I mean, the answer is very simple also. Self-supervised learning is the backbone for ChatGPT, right? If you ask me how is GPT trained, it's trained on next word prediction. That's what it has been trained on. That is essentially self-supervised learning. Next word prediction is a self-supervised learning task, right? So self-supervised learning is already useful. I mean, Yanle Kun talked about self-supervised learning and reinforcement learning 5 years ago, right? 5-6 years ago. At that point, we didn't have ChatGPT, right? So his prediction has already turned to be to fruition at this point, right? Self-supervised learning has already yielded results through GPT, right? So that we should already recognize. Self-supervised learning has already yielded results through models like CLIP in computer vision. So I don't think we need to even doubt that already, right? Self-supervised learning has already yielded results, right? So obviously it would only yield more results, but models like GPT and CLIP have already done this. That's important to recognize. And Yanle Kun stated this 5 years ago, right? So things have already shown fruition of that idea. Can RL be used to solve real world problems? Is an interesting question, right? Yes, and I mean, one could argue that RL is being used in some way, but a lot of RL is currently used in synthetic settings. I think there is a more layered answer to this. I don't want to get into it at this point. I think RL is most useful when the symbolic entities on which you build your policies are very well defined. Right. I think we are going through. Okay. Let me try again. I'll have to back up a bit and explain this a little high level. I'm not sure who asked this question, Monojit. I'm not sure if Monojit is still here.
Yes,
Sorry.
sir, I'm here.
Okay. So I can slightly back up and say that the entire space of information processing, right? So from cognitive psychology, one theory for it, right? There are many theories for this, but one theory for it states that it operates as perception, cognition, and action. This is considered to be a loop, right? When you're first hearing me, you first perceive, right? Be it in hearing or seeing, you first perceive. By perceive, what you mean is look at the colors, look at the edges, look at the textures. That's perception. Or you probably detect the object. All that is perception. Then you cognize. Cognize is where you strategize, you reason, you try to say that, okay, this person is like this person is trying to do this. All that is cognition, right? Perception is just seeing it as it is. That's it, right? Cognition is one layer of reasoning behind it, right? So there are also one can also connect this to system 1 AI and system 2 AI, type 1 AI, type 2 AI, so on and so forth. You could also look at that as perception and cognition. But information processing states that the third part of that loop is action, which is where RL comes in. RL comes in when you manipulate your environment. You first perceive the environment, then you cognize out of the environment. Right now in this meeting, you first perceive probably me seeing the image, so on and so forth. Then you cognize by thinking over what I'm saying. That's the cognition part of it. Then you act by coming back and asking me a question. This is the PCA, or the perception, cognition, action cycle, that's going on right now in this meeting. This happens everywhere. When you pick up an object, you first perceive, then you cognize that that object is made. Let's say you're picking up a coffee mug. Then you cognize that it's made of ceramic, and then you act in a particular way. If the coffee mug was built out of glass, you would pick it up in a particular way. If it was built of foam, your hand would pick it up in a particular way. If it was built out of cotton, your hand would pick it up in a particular way, right? The action part of it changes based on what you cognize out of it. And once you pick up the glass, your environment changes, you intervene, and the PCA cycle goes through again and again as a human feedback loop. Okay, this is one theory of how information processing works. Now, RL is in the action part of it, right? RL is all about how do you manipulate, how do you take a policy and navigate the environment, how do you manipulate the environment. That will become successful when perception and cognition are well understood. Let's say that you did not know that you can never identify that your coffee mug was made of ceramic, glass, wood, or cotton. If you now try to pick up the cup, you will fail. No wonder RL will fail if you don't have clear cognitive understanding of the scene. For the last few years of deep learning, we have solved the perception part very well. I think currently we are going through a phase where we are all trying to solve the cognitive aspect of AI. That's the phase as a civilization that we're going through. Once this is very clear, right, and we understand the symbols that we operate, we are able to talk about our using a camera. I'm able to talk about the various entities, reason about the several entities, what strategies are you doing, and all of that. The moment I get very robust systems on that, acting in that space will become easy to do, and RL will become very important then. Which is the reason why Jan LeCun called RL the cherry on the cake, right? He called that the cherry on top of self-supervised learning and supervised learning, right? So can RL be used? I think yes. That's my personal opinion. Please don't take this as everybody's opinion. This would be my personal opinion. Nobody can predict the future. We can only opinionate on the future. This is my opinion on what RL could do, right? Not the absolute truth. But this is my opinion that RL will be useful, but we have not yet got to the understanding of the cognition part in a very, very robust way. The moment we can do that, you can probably build on top of it using RL. That would be my high-level answer to your question, Monojit. Hope that answered at least in some level.
Yes, sir. I have one follow-up question.
Sure.
So, for the last few years, it seems like RL has kind of stalled. So, do you think in future there will be a kind of breakthrough? RL will make a kind of
I'm saying
major.
yes. Yeah, I'm
Okay.
saying yes.
Okay.
Exactly yes. I'm saying that, but it depends on the substratum being solid, then only RL become useful. See, suppose I ask you to play a game, right? RL is, I hope you agree, is like playing a game, right? So it's like, I mean, that would be the more tangible way of seeing it. But I have not finalized the elements of the game. Can you play the game?
No, sir.
Right? So you have to help. If you want to play chess, I have to tell you that there are 16 pieces on the board, right? On each side. That there are black, there are white, there are black squares, white squares. Once I fix that, you can play chess. If I tell you that I have not fixed the pieces, I don't know what shape they'll be, I don't know what color they'll be, they could be anything. I've not yet figured out a way to finalize that. Go ahead and manipulate and play the game. Can you do it?
Difficult, sir.
So we are in that phase where we are still trying to fix the stratum, right? So, but once that is fixed, I think RL will play a better role. So that would be my answer. Again, my opinion, right? So I'm not saying that this is the absolute truth, but this would be my opinion, right? So any prediction on the future is just an opinion, right? Nobody can be absolutely right.
Yeah, sir. And recently I also saw decision-based transformer. So it is RL with transformer together. This is decision transformer. So I think yes, sir.
Right. So I
Thank
do
you, sir.
feel it has merit.
Got it. Thank you, sir.
Okay, the next question, we will keep a tab of time. We may have to have a hard stop at 7:45. So bear with me for that. I'll try to do as many questions as possible by then. I think we've finished most of it though. The next question seems to be, I'm reading out from chat. It's from YouTube, which says, my research is on student engagement level in the classroom. I want to know the best algorithm to analyze the student image or video in live and detect what is the level. We've actually done some research in this space. We actually released a data set in the space called DAISE, DAISEE. I would recommend you to look at that in the past. But my answer would be exactly the same to what I answered to some of you in the past. First, finalize your data set. Create a data set if you're not already aware of what you want to use it in. Once you create the data set, use some standard existing algorithms to do classification on your data set. Use vision transformers, use CLIP, use some basic well-known models to do it on your data set. See what works the best. Then pick the best performing model. If that accuracy is not enough, find the failure cases, see how to improve that model. It's the same answer that I gave earlier. It's just a different application, right? So that's the same process I would recommend even to address this problem. I hope that answers this question that came from YouTube. The next question seems from Ashutosh, which are, what are future directions on geometric computer vision for camera-based perception? I think Ashutosh, I already answered that question. Hope you were there to hear that, and I hope that answered that question. Okay. The next question is from YouTube again, which is, NPTEL provides free courses, but in parallel, IITs also provide paid courses. Is there any difference between the curriculum? Yes, there is. Otherwise there would not be a paid version. So I think I assume you're referring to the IITM, say BS in data science. So yes, there is. I think you get more. The content also changes in certain courses, not all courses, but certain courses content also changes between NPTEL and the IITM BS course. Many of the IIT courses also give you projects where you can work on, because it's a smaller group. You can also do projects. There is also a more live person to ask questions and interact with. The content is also different. There are live sessions to answer questions, so on and so forth. So in short, the answer is yes, there is a difference. So the paid courses do have components. And there's also a more closer peer community interaction inside these IIT courses. So the short answer is yes, the two are different. May not be at just a curriculum level, but at the treatment of the curriculum level, there is definitely a difference. Okay. The next question I see is from Rishabh Mondal, which is, I'm a research scholar at IIT Gandhinagar. I'm working on satellite imagery with the objective of geolocating small objects in satellite images. The main problems I face is that the pixel distribution changes across different images, which leads to a drop in recall. The object I'm trying to detect is also sparsely distributed. Our model YOLO is unable to generalize well. Can you provide suggestions? This is in fact an active research problem in my own group here at IIT Hyderabad. So I'll highly recommend you to follow not the mainstream object detection literature, I'll highly recommend you to follow the drone-based object detection literature,
Sir,
which is also
can I
the
interrupt?
tiny object detection literature.
Sir, can I please?
Sure, sure, yeah,
Sir,
go ahead.
actually, sir, what is the thing is, we don't have the ground truth. Firstly, and the object is mainly very actually, it is a very unorganized air pollution, a source of air pollution, what we are want to detect. So, drone-based approach is not possible for that reason.
No, no,
So,
I don't think you heard me completely.
yeah.
I was trying to say that I was not saying drone-based approaches. I mean, drone-based, what I mean is don't look at the mainstream literature in object detection. I was trying to say that drone-based object detection and similar communities have specific methods for tiny object detection. I was suggesting you look at that literature. I'm not saying use drone-based approaches. I'm
Okay,
saying
okay.
that
Sorry, sir.
I was saying there's a separate literature on tiny object detection.
Tiny up.
I was saying, see that literature to get methods. Don't look at the mainstream
Okay.
object detection. You're absolutely right. As I said, like we also work in that space. You're absolutely right that the mainstream object detection literature does not work in such problems.
Yes,
You're
sir.
absolutely right.
And also, I am trying the self-supervised learning in not too much effective in that case also. For domain adaptation kind of things.
I understand.
Yeah.
Yeah, look at the tiny object detection literature. That's the
Okay,
literature that
okay.
especially looks at that. So those are the methods that operate in this space.
Okay,
There
sir.
are, if you search tiny object detection, you'll see papers on that.
Okay. Thank you.
Specifically focus on that. Yeah.
Okay, thank you.
Okay, I think there's one comment from Sigbatullah Ahmad from YouTube, which says, in the case of the electric meter question, would image model segmentation work? Yes, but I think his question was more about how do you get the numbers from not just segment, but how do you get the numbers from the electricity meter, which is a text extraction work. Right. So for that, anyway, I think the answer that I gave was to look at the literature that comes from the document analysis and retrieval community. So I think that would be the right literature. Segmentation could be one step towards that, but there are papers and the community, there's an entire community working on that. I would have ideally recommended that community for understanding that. Okay, there's one other question. Okay, I think Swarnim has already answered Ashutosh's question of distance from camera. Absolutely right. Please look at monocular depth estimation. In fact, there are many papers on just depth estimation with a single image. There's already literature on that. There's enough papers on that for you to look at, Ashutosh. Okay, I think we're almost done. I think there's one other question from YouTube. Should we be more generalist or specialist in our approach to become a good researcher in machine learning? I mean, this answer is very simple. You have to be a specialist initially. You have to be a specialist initially. Right? It's important to be good in something first before becoming good in everything. Right? Good in everything comes from experience. You should first be good at something. Right? So I would ideally say become a good. But if you mean specialist in terms of theory versus application, I would have a different answer. Right? So if you say, should I become good at object detection versus good at becoming agriculture? Right? So that's a separate answer. I don't know whether the question was which context, but in a more general sense, I would say be a specialist first. Be good at something first before you generalize. Okay. I'm slightly going a bit fast just to ensure that I cover the last few questions. There's a question from Venkat Sai, which is on, please comment on computer vision and digital twins. If I want to map multiple CCTV camera frames at a particular timestamp, look like digital twin for ease of monitoring as a single scene, how can they work together? Oh, this is a very hot topic. I think bringing AI and digital twins is a very hot topic. Multiple companies trying to do this. I personally know companies that are doing this in the in smart city space, in the shipping industry space, so on and so forth. Everywhere, I think people are trying to see if you can bring the two together, then it's very, very powerful. I completely agree. But it's a very, very large project. It's not a small scale project. Doing a digital twin has to be studied properly. right? I think it depends on at what scale you want to build a digital twin. You can build a digital twin for an entire organization. You can build a digital twin for a particular room. You can build a digital twin for a particular road. You can build a digital twin for a particular city, right? So everything has an approach. So I think it depends on the application. If you ask me, is it an important problem? Absolutely, yes. I think many companies want solutions in this space. I don't think it's a solved problem, right? So it's an ongoing problem, as I understand at least, right? So it's a very hot problem, but I think you have to study it at an appropriate scale to solve it, right? I don't think you can solve the entire problem at one go. You probably have to take a particular slice of the problem, solve it there first, and then expand. That would be my personal suggestion. But otherwise, yeah, I think it absolutely makes sense to take up.
Yes, sir. Thank you. But in case of a retail store or something like that, if I want to map the heat map of the footprint of the customers or something like that,
Absolutely,
and
yes. It's an important problem.
something like that, like
I think the retail
any
space will wrap it
resources,
up.
yes, sir, any resources like the paper journals or something like that, which I can focus on that.
I have not been seen this space much in papers.
Okay, okay.
Right, the intersection of AI and digital or CV and digital twins, I have seen, because I think I don't think any academic organization would have access to digital twins at scale.
Okay, okay.
Right, digital twins essentially is a scale problem.
Okay, okay.
Right, it's not a miniaturized problem. It's a scale problem, right? So I have seen this more coming from the industry than academia. So I have not seen too many papers in the space, but so yeah, very hard for me to tell where to look. But I mean, I would say definitely look for keywords on this. Ask ChatGPT to recommend you papers, or like look Google Scholar. I would definitely recommend you. But my initial answer is that I've not seen too many papers in this space. And the reason I feel is that this is more an industry problem. So I think you would probably, you may not find as many papers in the space, because for academia to take up this scale is not easy. So the papers in the space is not as much, I think.
Yeah, thank you, sir.
Okay, Monojit asks, can we have one more live session? Happy to do this. We can probably do one more. I thought maybe the third week of October, the week before the exam is when I thought we could have one more live session. We'll do that. Okay, it is 7:45. Unfortunately, I have to leave now. I mean, I know there are a couple of questions, but as I said, we'll have one more live session. For those of you who asked the question towards the end, I'll highly encourage you the next time, please do ask the question through the Google form when NPTEL office shares with you. I think that helps me ensure that I cover your question in time. We may have to stop here for today, considering I have some other things. I have a meeting coming up, so I may have to stop here. But I hope this session was of use to most of you. For those of you whose questions I could not get to, I think I can see only 2 questions, and probably even that question, I think part of it I already answered. So please do come. You can please feel free to come back to the second live session the next time. Happy to answer questions. For those of you whose questions I took time, I came back only towards the end. Please post your question on the form, right? So that way we'll go in the same order in the next live session too. So that way I respect people who've taken the time to post the question first. Okay, we will have one more session. Thank you for your comments, and I'm happy if it is useful. We will have one more session. I'm thinking of the week before your final exam, right? So that will be the session where you'll have the question session. That'll be the week where you'll have the session. Okay, let's stop here. Thank you also for all the questions. Thank you for the interactions. I think that's what makes the session useful. I think some of the questions made me think too. Some of them I don't have an answer to. I'll probably go back and try to dig up too. Yeah, happy to have one more session and keep this more interactive. Thank you all again, and hope you enjoy the remaining part of the course. We are happy to take suggestions on the course too. Maybe the next time we have a live session, I'll try to keep a few minutes just to take some suggestions. As I said, based on the suggestions, we kind of revamped the course from this time. So we're happy to take more of them as we go. We'll stop here, and yeah, see you all again, and in a few weeks, and hope you enjoy, and hope the remaining part of the course is useful to you. Thank you all again.
Thanks so much. Thanks for your time.
Thank you, sir.
Most welcome. Thank you.
Thank you, sir. Thank you.
Absolutely.
Thank you, sir.
Okay. I'll request the NPTEL office to perhaps close the session.
Thank you, sir.
We are done with today.